So for lesson 89, we're looking at quadratics again. Degree of 2. We're looking at graphing them. We're also looking at inequalities. Inequality symbols include what?
Greater than,
Less than or equal to, greater than or equal to. Less than or greater than. Technically, we could also say not equal to since it's an inequality, not equal to. So. But we are looking at those inequalities as we look at them with the quadratics. So for example number 1, we are graphing y is equal or greater than negative 2x squared plus 12x minus 16. Little review before we get into it. How do we go about graphing this thing? What do we need to use? It is the key, it is the form that we have struggled to memorize all year long. So this is why we're reviewing it again. What do we use? Peter?
I have no idea. I was going to say quadratic formula, but...
Well, we want to use the quadratic formula to solve this thing if we wanted to know what it is when it's set equal to 0. But we want to graph this thing. Huh? We do want to find the vertex. Very good. So how are we going to find that thing? Tanner? There we go. Good. You were saying it too. We need to use x is equal to negative b over 2a. And this is going to help us find the vertex of this. Now again, the vertex is an ordered pair, correct? It's an xy pair. Which means this will give us the x value of the vertex. B value is 12, so negative 12. A value is negative 2. Negative 12 over negative 4, I'm coming up with my x value to be 3. Again, the vertex, it's an ordered pair. My x value I found to be 3. How do I find the y value? Tanner? Yeah, you take 3 and you plug it in. So, 3 squared, 9. Negative 2 times 9 will get us negative 18. 12 times 3 will get us minus 16. Negative 8 and 36 will get us what? Two. I'm asking you to simplify negative 18 plus 36 minus 16. Well, that's not good. It's 2. There you go. Alright. We have to know this process, because I can tell you, and I know this graphing and quadratic equation is on that semester test. Okay? Standard form, ax squared plus bx plus c, and that's what we're in, standard form, negative b over 2a. That's your starting block. Find the x value. Once you get the x value, plug it back in, get the y value. Okay, so we had to do a little bit of work to find the vertex. But there it is, 3, negative 2. What do I know about this thing? Is it going to be a line? No. Okay. So hopefully I don't see any more lines when it's a quadratic come test time anymore. But instead I see these parabolas, these u's, right? We know that we have the axis of symmetry that's going to go right down the middle of it. And it's going to be symmetrical on either side. So now we ask the question, well, what x values do I want to solve for? All of that is dictated off of your axis of symmetry. You can go to the left or the right. If it's me, it looks like I could use 1 and 2. Notice the x value of 1 and the x value of 2 are both to the left. On your own, solve when x is... No. From Kyler on over to Jaden, you need to solve when x is 1. From Justin on over to Brock, you need to solve when x is 2. And when our x value is 1, what do we get for our y? Y? 0. Okay. And what do we get when our x value is 2? When the x value is 2, what'd you get?
Negative 14.
-14?
Yeah.
Others? Peyton, what'd you get? -8. Montana?
I got 0.
You got 0? Brock?
I was still working that one on,
Still working on it.
but
Isaac?
I got 0.
You got 0. Jade?
I got
0? Okay.
0. 6.
So this one is 0. This one you came up with -6. Very good. Okay. Let's go ahead and plot those. 1, -6, 1, 2, 3, 4, 5, and 6. 2, 0. We're going to flip this thing over. And there's that half. Now the thing is, I made a mistake. What's the mistake that I made? What's wrong with this graph here? No, I think we plotted the points correctly, the spacing, Caden.
The line's not like dotted.
Yeah, very good. Should be a dashed line, right? Go back to your inequality symbol. Y is greater than that expression, therefore it needs to be a dashed line. So, there it is. 2, 0. 1, 2, 3. So there's our dashed line indicating that we can't use any of the solutions that would happen to fall on the parabola. And then the last thing we need to do is shade this thing, correct? Now, you can use a test point if you want to. You could use 0, 0, plug it in and see what you get for a result. Or, hopefully the way you're catching on to it is, notice this expression tells us we want all of the y's that are greater than this value. So are we going to shade above or inside this thing? Above. Very good. And there we go. Dashed line to indicate that it's strictly going to be greater than that. Then also we need to shade accordingly. This process is nothing new to us. At the same time, we still struggle with it. That's why I wanted to cover it. Okay? Negative b over 2a. That's what you have to use. The new concept for today is when we want to solve this thing algebraically. Okay? So we don't need to graph this thing. Yeah? Instead, we need to learn this new process. X squared plus x is greater than 20, solve algebraically. First thing we want to do is set it equal to 0. So we'll subtract 20 to both sides. And let's just pretend it's an equal sign for right now. We'll deal with that greater than symbol after a bit. Now what have we been taught to do? Reverse FOIL, right? Okay, factor. So let's go ahead and do that. X and X. Factors of 20. 5 and 4. Where this is positive and the 4 is negative. And then again, if it was an equal sign, we would do 4 and -5 and the game would be over. We'd be all done. The thing is, it's an inequality symbol again, correct? So it's going to change a little bit. Those solutions of 4 and -5 are no longer solutions to us, but instead they're going to be called critical values. Because again, understand with inequalities, it's not just a particular number that's going to make this thing true. It's going to be an interval. x is greater than 4, x is less than -7, and so forth. Okay, and it's these critical values, 4 and -5, that are going to help us establish what our intervals are going to be. So therefore, let's go ahead and create a number line. Don't have to get fancy with it. Well, let's indicate -5 and let's also indicate 4. Because again, we want to establish the intervals that we're looking at here. First interval is going to be all of these x's that would happen to be less than -5. The next interval are all the values that happen to be between -5 and 4. And lastly, we could be looking at all the x values that are greater than 4. 3 intervals that we've created here. Again, all going back to those what used to be solutions but are now considered to be critical values. And now that we established our intervals, we can go ahead and set up our chart. We have the interval, we have the test value, and we have our possible solution. We're going to determine whether or not it's going to be a solution to it. What did we say the first interval was? X is less than -5. Very good. What was our second interval? Well, it's going to be all the x's between -5 and 4. And the last interval? X is greater than 4. Again, we developed that from our number line. And that's why I like using the number line, because it helps us establish, okay, this is one interval, that's the next one, that's the third one. If you have 2 critical values, you're going to have 3 intervals. Suppose you had 3 critical values. How many intervals would you have? 4. If you had 4 critical values, how many intervals would you have? 5. Very good. Next thing we want to do is we want to pick a test value that's going to fall within each of these intervals. Okay, so let's start with this one. X is less than -5. Well, let's go with -6. Test value that's going to fall between -5 and 4. 0 is always a nice number to work with. And lastly, test value that's greater than 4. I would pick 5. You can pick 10, you can pick 20. It's something that falls within that interval. And lastly, we need to determine whether or not this test value is going to be a solution to this inequality. So if we look at -6 and we go back to our original inequality, x squared plus x is greater than 20. I plug -6 in. -6 squared will get me what? Plus -6. 30. Is 30 greater than 20? Yes, it is. And again, for me, a check mark is a good thing. If we try 0, 0 squared is 0, plus 0 is 0. Is 0 greater than 20? No. And lastly, if we try 5, 5 squared is 25, plus 5 is 30. 30 is greater than 20, therefore yes. So you're going to do all this work. You're going to, find the critical values. You're going to set up your number line. You're going to set up this chart, and this is what you come up with. What's your final answer then? Because I will have students that'll do this entire process, but then leave it like this. And I cringe because it's like, oh, you did all the work. All you got to do is write down your answer now. So what are our answers?
65.
Yes and no. Okay, we did find -6 to be true, and we found 5 to be true. But we need to be more specific, because it's not just -6 and 5. Tanner?
X is less than X is less than -5 and then X is greater than 4.
Again, it's an inequality, so it's the intervals. We could have x is less than -5. We could also choose an x that would happen to be greater than 4. we're gonna practice the same procedure, working with problem D.